I would like to welcome you all to the fifth seminar of AI and CSS seminar series of GLODEM. Actually, we are co-hosting this event with the Department of International Relations, and we have the great pleasure to host Dr. Onur Varol today, and he is going to give a really exciting talk on modeling individual and group behavior in complex interactive systems. Before I give the floor to Dr. Varol, I would like to also briefly introduce him to you. Onur Varol is an assistant professor of computer science at Sabancı University. He holds a bachelor's in electronics engineering and in physics engineering from Istanbul Technical University, and Master of Science in computer science and engineering from our very own Koç University, and a PhD in informatics from Indiana University. Prior to joining Sabancı University, he was a postdoctoral researcher at the Northeastern University Network Science Institute. His viral lab focuses on computational social science, networks, and machine learning. His research activities focus on modeling user interactions, leveraging online data across multiple platforms to understand conscious and unconscious behaviors. Without further ado, the floor is yours, Onur Hocam. I'll mute myself.
Thank you very much again for the invitation. This is a really exciting talk for me, and I'm hoping like this will be a great beginning for the 2021 for all of us. So today I would like to talk about some of my research agenda and the research that I conducted in the past couple of years. The title that I picked for this talk is Modeling Individual and Complex Behavior in Complex Interactive Systems. So I will describe in this talk mainly for the tools that we have been developing to study online systems, mainly for the political analysis, which is the Botometer systems. And with this tool, we conduct some large-scale analysis on Twitter, looking how these human bot agents interact in social platforms. And then doing a case study for the 2016 US presidential election. And I would like to then further discuss type of research that I've been currently doing in my lab at Sabancı University. But one thing that's really exciting for me being able to present this audience is like how well the interdisciplinary boundaries are removed and we can collaborate with each other. And computational social science is one of those where different disciplines came together, which I greatly admire and find it fascinating for my own research. And you may have seen like different applications of computer science in different fields. Recently, we have the DeepMind paper for AlphaFold solving problems in biology. We have seen art and computer science coming together. And this is not it. Like we can think of computer science and many other disciplines came together and collaborate and address important and pressing problems. We can think CS plus biology with journalism and applications for engineering in economics, politics, chemistry, psychology, law, and arts. You can name many other fields that can combine and bridge together. But what is more important is beyond developing those techniques and using for analysis is being able to interpret those results. And this is where we need specializations and interdisciplinary collaborations. So if you think about like a three-dimensional shape that might correspond to a shape of science, what you can imagine, like I would like just for a second for you to imagine. And for me, this is an important question because it helps us to navigate in these scientific disciplines and boundaries and find a place where we can make the biggest impact. And actually, what we can call shape of science is simit, or if you are from Izmir like me, you can call it gevrek. And this is not just a joke. If you look at like the co-citation network for different disciplines and the journals for those disciplines, it's actually a circular shape. We can see engineers tend to collaborate with management schools, and then they collaborate with cognitive scientists and other fields of social science. And then we see those disciplines collaborating with medical sciences, and then they make a full circle. But what is missing is going from computer science or engineering directly to the social sciences. And these are the well-novel research that we can conduct. That's why I like this analogy a lot and try to put my research along these directions. And if we go back, like when I study social networks, I look for the historical perspective as well and think about like more in terms of like in a communication sense. We have newspapers, telegrams in the early 17th, 18th centuries, which help politicians to go for doing public speeches. With telephone and telegram, this communication getting much faster and rapid and more efficient. We started to hear politicians going on radio and reaching hundreds of thousands of people. With the television become more popular, we started to see it becoming a medium for first presidential speech, for advertisements, and for healthy democratic debates on television. And moving forward, like about 30, 40 years, we have the internet, and it brings a totally new ways of studying those interactions. We have the Reddit platform, we have Twitter, we have Facebook, and on this platform, different than the previous different mediums, we can see it is not one-to-many medium, but it become many-to-many. So we see politicians are participating those debates, interacting with the voters, and even arguing and discussing with each other on these public mediums. And once we have such an environment, such an ecosystem where everyone can participate and raise their voice and share their opinions, there's also a potential venue for manipulation. And one of these mechanisms people are manipulating social media is through social bots, automated agents participating in these platforms. And we see evidences, examples of those social bots manipulating stock markets, used for political smearing, AstroTurf campaigns, purchasing fake followers to look more popular and influential. And nowadays, like using social bots for marketing, spamming, and social pollution become a norm. Like it is kind of expected, no one's surprised by that. But what is more concerning is if one can use those automated agents for affecting mood and behaviors of others. And that's why I find a motivation to study those entities. And by a recent review article by Stefano Kresge, he lay out the importance of the problem. He looked for different countries and finding out these publications, finding evidences for potential manipulation through automation. And there are over 39 countries, several publications about those countries and how these technologies used for manipulating online conversation. And when he was laying out the evolution of social bot research or manipulation research, he put a couple of key publications here, and it's a growing field. Luckily, I was lucky enough to participate in a couple of those papers and conduct my research in this area early on, and now continuing to building on top of those to developing a better systems and applying those technologies to different venues. And one thing that I wanted to clarify, when we think about humans and bots, people tend to think about this as a binary labels. So some accounts can be either humans or fully automated. But there's lots of things in between in these human bot spectrum that we can see different levels of automation. And bot developer can use these technologies to make a profile more human-likely. They use automation strategies for content or network generation, but they might also use intervention by the human. So it's not like a binary problem. And in order to identify those accounts that might have used automation, I developed a tool called Botometer. It's an online platform where you can submit a Twitter username, and then our machine learning models analyze various features extracted from the Twitter profile and the content generated by those accounts. And we end up having scores to evaluate those accounts in along different dimensions. So when I first developed the Botometer, it was now we can call it traditional machine learning application where we extract various number of features, really engineer those features with our domain knowledge, and looking at user network, friend metadata, temporal characteristics, the type of content the user is generating, and the sentiment of those content. So we built a large collection of features to identify bot accounts on social media. And in our initial evaluations, we look for different learning algorithms to benchmark our performances. We have ensemble models like random forest achieving not surprising high accuracy than other simpler models. When we look at different feature groups, looking at the user features, content features, we see they are helping us to identify those accounts. Some of these other features are not as helpful. And these evaluations are conducted in initial data sets, which was collected in 2011 called Honeypot data set. What this data was doing at the moment was they created an account, and all these accounts were creating some gibberish content, the content that has no meaning. And they are looking which accounts are following those content creators. So if someone following a gibberish content, that means these people are not like really humans or interpreting those results, and they assume all of these accounts being social bots. But moving forward a couple of years later, when we are using our models in the real world setting, we realized sometimes we made mistakes, and we investigated why those mistakes can happen. And we recollect some additional data sets manually annotated in 2016 and look at the comparisons when we retrain our model. One thing that is quite surprising is human accounts remain similar in these 5 years, so they don't really change the behavior. So our machine learning models evaluate these human accounts the same way, whether it's collected in 2011 or 2016. But when we look at the bot accounts, we realize our model having difficulties to identifying more recent bot accounts. They are using the recent technologies. They become harder to spot. They use different types of automation technologies than simply retweeting each other or copying and pasting content from other accounts. So now this problem is become much more challenging over the times. And of course, we made mistakes by those models. When we investigate the type of mistakes that we have been doing, we know like neither humans nor the machine learning models are perfect. So we as humans lack these computational power and memory capacity to analyze all these patterns and data within the accounts. Machine learning algorithms are definitely doing a better job on that. But algorithms can also do mistakes. For instance, the false positives that we commonly see is very active accounts. And sometimes these active accounts might also use these automation technologies, but we tend to label them as humans sometimes. Or there are some false negatives like organizations and foreign language tweets. Especially for organization, it's an interesting case because there are a group of people controlling those accounts, and sometimes they can also be misinterpreted by the models. And that's there's a reason why we keep developing the botometer for further, because of this arms race. Every time we develop a better model using different features or having more comprehensive training data, the bot creators also tend to develop their own approaches. So when we developed the first botometer version 1 back in 2016, it was a public API. We wanted to showcase this system, open it up to public and researchers where people can query and collect their own results. We realized the shortcomings of those approach, and we collect finer data, more sophisticated models to address. And then we use those models to answer some of the questions like what is the prevalence of social bots in social media, which I'll be discussing next. And then we refine the models by adding additional data sets, updating some of the features, and addressing the current needs of like what type of features that we can develop to catch recent models. But one thing that we are kind of like struggling with the botometer as well is the performance, because we try to develop an accurate model at the time, and we try to get, so when I was developing it, I had two primary concerns. This tool should be fast, and this tool should be accurate. And we try to eliminate as much data as we can. So we are making only 2 requests to Twitter, one for getting the content and one for getting the search results. But even making these 2 requests to Twitter can be sometimes time costly because we need to rely on Twitter's API. So one of our PhD students developed a light model for Botometer, which works only with profile information where we can gather from historical data. And these models can also perform temporal analysis going back to older data sets that we collect. And this approach has pretty similar accuracy, not as much as Botometer, but significant improvement for speed and scalability. And recently, we are addressing a crucial issue of out-of-domain performance when we encounter with the novel bots, how our models can generalize for those. And this is the latest version. And in my lab, we are developing deep learning technologies for extracting information from content, network, and some user metadata so that our models can better generalize and can be applicable for different languages and domains. So when I was describing the Botometer version 2, I was mentioning the study that we conducted for large-scale Twitter accounts. So for that, we even had problems with Twitter to gather such data and conduct this analysis, but that's a story of another time. So we collected information for 14 million Twitter accounts. With that data, we could estimate the bot likely population on Twitter. We studied information flow between different entities, and we analyzed how they structurally connected and what type of behavioral clusters that we can observe in this data set. So in order to estimate bot population, we train different models with different levels of sensitivity. We start from a simple model where we have only the honeypot data, simplest bots possible, and then by adding to this mixture more sophisticated accounts, we tune our models for different levels of sophistication. And applying those models to our 14 million data set, we estimate to what percentage of those accounts are being social bots. So our estimates were between 9 to 15% of active accounts have automated behavior. And that was in 2017. When we released that data, put our paper on arXiv, it was like an interesting story in social media because many people were complaining Twitter were releasing 5% estimate to their stockholders. And our result seems to be much higher. So they were concerned we were overestimating. But just within a month, the ISIS campaign, the radicalization on Twitter platform became an issue, and Twitter turned out to be more proactive, deleting and suspending those accounts. And within 3 months, they deleted 45 million, more than 45 million accounts in their network, which is aligning very well with our estimates at the time. So to explain better for the next couple of figures, I will just show a caricature image so that it will be easier to follow the next couple of slides. So here we have a Botometer score on the x-axis, and the y-axis is the density. So for human accounts, we know that Botometer score should be lower. Closer to 0 means they are more likely to be a human account. In the middle, between 0.5 to 0.7, we have more sophisticated bot accounts. And bot score having closer to 1, 0.9, they are the simplest type of bot accounts that our models can easily detect. So by taking into consideration these images, we can now look at how the information flow differs for different type of accounts. So here you can see 10 different lines with 10 different colors. And each of these lines corresponds to a group of accounts. So we look for, let's say, the blue one is human accounts, and who mentions these human accounts. And the yellow one tends to follow for bot accounts, and we can see who mentions or retweet bot accounts. So for mentioning, we see humans tend to mention on other humans, but bot accounts tend to mention each other. And for retweeting behavior, sophisticated bots engage these interactions of their own kind. So they build these, let's say, botnets that kind of like promotes their own content by retweeting each other. And we see simple bots retweet each other while mentioning more sophisticated accounts for the information flow. For social connectivity, there's nothing surprising if when we look at the friends and followers, so there's some type of homophily, they tend to friend and follow accounts that are similar to each other. But when we study the reciprocation rate of those accounts, what we see was humans have higher reciprocation rates, about 0.7 for reciprocation scores, and we define reciprocation by the overlap between friends and followers divided by the friends. So humans are better at reciprocating when you follow them or if they follow someone. But for bots, we see a bimodal behavior. So they are either not reciprocating at all or reciprocating pretty much all the other accounts. So in one behavior, when they don't reciprocate at all, these simple bots are following people at random and they never get followed back. In the other end of the extreme, when the reciprocation is high, these are the bot armies that follow each other to build these high dense clusters. And of course, by looking at the features that we extracted and representing those feature representations in a lower dimensional space, we can look at the clustering of those bot behavior. We have spam bots that kind of cluster very well together. We have self-promoting accounts. These are the advertisement accounts for recruiters and business professionals coming together nicely. We have a group of accounts that use a mixture of these sophisticated and bot accounts. So they are using some type of automation, but some of the aspects of the account is more human-like or controlled by humans. And one interesting outlier that we observe in this embedding is accounts that use automation apps. So that's why I'm always critical about the third-party apps in any social media platform. When we observe those accounts, what we see was these are dormant accounts. The owner of the accounts doesn't use Twitter at all anymore. But what we see in the profile is same YouTube links, same Instagram links over and over again, because they connect their Twitter account to YouTube or the Instagram or the Spotify that they have been using. So those third-party apps is posting on behalf of those users. And the reason I'm more concerned about these third-party apps is Twitter is not deleting or suspending those dormant accounts. And one concern is I can create a really simple third-party app. Let's say I will create a word cloud of your content, and people give their authentication to my application, so I can perform certain actions on behalf of them. Those actions could be posting on behalf of them, following and unfollowing people on behalf of them. And then once I monitor and realize those accounts are dormant, what I can do is deleting the content of the profile and create a new persona, or suddenly start following a certain campaign, or suddenly start posting certain hashtag. So these are kind of like a waiting time bombs if we think about these dormant accounts. So briefly, with the Botometer, we studied these social media platform and estimate the 9 to 15% of accounts being bot-like behavior and characterize the information flow and social connectivity for the first time. But we see further evidences, further use cases for social bots during the election time. There are several different publications in this pressing issue in the subject. Pew Research Center conducted their own analysis to highlight the scale of the problem. They were using Botometer, which was like really great for us. We were happy to see Pew Research Center using our tools. And we were also interested in studying the dissemination content at this time in the election. And at Indiana University, where I did my PhD, there was also another tool called Hoxie. So we have a large ecosystems of these tools developed for studying social media ecosystems, specifically for manipulation purposes. And with the Hoxie, we were collecting content generated by different news agencies. These are the accounts sharing URLs for low credibility sources or fact-checking organizations. So fact-checking organizations, for instance, factcheck.org, Open Secrets, Snopes, these are the most popular ones that are putting a gigantic amount of effort to validate and fact-check the content online. And the Hoxie is a tool to collect and gather all these information for studying election or any other misinformation campaign. And behind the Hoxie, we are using Botometer to study social bots as well. So if you use Hoxie platform and visualize the spreading pattern of a meme, you can see each node is colored by their Botometer score. So you can visualize where the bots are trying to push a content online. And these are two of these dissemination network that I can give example. One of them is an factual article. The other is a misinformation campaign. The one on the right, the large one, is this Hillary Clinton sprit cooking campaign. This is like outrageous claims done during these election time. And they were like claiming Hillary is a member of a organization. They are kidnapping kids and things like that. So there's a huge chain of stories about that. But what is concerning when we look at these different types of stories, misinformation stories and fact-checking stories, they tend to have similar levels of popularity if we randomly sample them on social media. So they have an equal chance of getting viral on social media, whether they are fact-checking or misinformation. So that's why we wanted to identify those misinformation content online or visualized through Hoxie platform, where journalists and other social media practitioners can use. So one thing that we studied during the election was looking at the dissemination, how bots are disseminating these low credibility content. And we look at the fraction of tweets posted by these likely bots, and they are at really high rates appear in the low credibility sources. Fact-checking organizations have pretty much on about 10 to 20% social bot participation rate. But when we look at the low credibility sources, especially the ones that are not reaching really viral level, they are pushed mostly by social bot accounts. And one of the concerning facts that we observe was, as the low credibility content getting more popular, participation by humans are increasing. So humans are joining the conversation and bots are no longer needed. Bots are making the initial push to make it a more popular viral look. And that's why we need to identify and be proactive detecting those misinformation content early on. And if you look at like retweeting patterns by those content, one thing that we observe, majority of these retweet activities, misinformation content shared by thousands of times, most of these retweeting activity is actually done by humans. Humans is the responsible party for disseminating these bot-generated contents, because bots are making a appearance of those content being viral and more visible early on. Another strategy that bots have been employing is being early. So they try to be the first one to publish, first one to retweet, to create those illusion of popularity that I mentioned earlier. And they are also more strategic. So they try to mention and target popular accounts, because if, let's say, 10,000 bot accounts mentioning the same person with the same URL, they're more likely to believe and share with their audiences. When we first think about it, when we first generate this hypothesis, we were thinking like, no, people with such high popularity should be more responsible and be aware of like the misinformation content. But actually, in the past election, it turns out to be not the case. We see Donald Trump retweeting misinformation content many, many times. So once bots are targeting a popular account like Donald Trump, then a retweet action is actually disseminating this content to 70, 80 million people who follow Donald Trump accounts on Twitter. So that's why this strategy is seems to be hard to achieve, but once it happens, it's actually really effective. And by studying the election, we show the differences between low credibility and fact-checking articles and the challenges for distinguishing these two. We use Botometer to study those, and we characterize how bots have been employing different strategies to gain popularity and influence accounts online. And luckily, I mean, one thing that I really find myself lucky by doing this research is We try to make a real world impact by doing that. So as a result of the research, our colleagues have been engaging with policymakers in US. So now there's a law how social bots should be regulated, what are the consequences of using social bots, and they've been using evidence from our papers to emphasize the importance of the problem. And I find this quite nice because it's not really common where we see our research is touching actually the real life and having real consequences. And another thing, like when I think about how social bots can be used, is actually the gatekeepers. And the gatekeepers, what I mean by the journalists, they have the big responsibility in these misinformation ecosystems, how they conduct their journalistic practices, how they regulate and analyze the content before going to the public. But in the age of internet and use of social media, it's become much more difficult because they are exposed all these opinions of the people online. They get this constant reinforcement loop, positively or negatively, and their opinions are influenced by those. So in order to characterize and study how journalists have been using social media and what are the influences of social bots for their practices, we collected journalist accounts online. We look for keywords like in their bio, reporter, journalist, executive producers, and such. And since this is mainly focused on English language, we see a majority of the accounts that we collected coming from US, Europe, and India. And one thing that is quite fascinating is majority of these journalists' accounts are verified accounts. So verification status is one thing that is really important for journalists. So they apply proactively to Twitter, get this verification status. When a journalist account created early on, let's say 2007, 2008, there was a significant chance their account get the verification badge. But recently, after 2016 to 18, these numbers getting much more lower, and actually Twitter stopped giving verified badge to accounts last year. I think they are restarting it now with more control. But one thing that we wanted to answer is why this fraction of verified status on journalist accounts getting much lower. Is it because Twitter is more strict, or there is more low quality accounts presenting themselves as journalists? Because it is easy to call yourself journalist on Twitter and gain lots of followers to share your opinions. So we try to quantify bot presences in a journalist network, and we detect distinct patterns of those interactions. And we also look for the effect of this perceived authority brought by this verified badge program of Twitter. So first, we can look at, depending on the account creation time of those journalists from 2007 to 2018, we can look at those journalists' fraction of bot followers. If a journalist account created early on in 2007, 2008, they tended to have higher fraction of bot accounts in their network. As they become recent and still getting the verified status, they tended to have lower bot fraction. But what is surprising is verified versus other non-verified journalists, accounts who claim themselves being a journalist, the difference between fraction of bot followers are increasing. As we get more recent, there is more journalist accounts boosted their popularity by the bot followers. And that become more apparent when we repeat these analysis conditioned on the number of followers that we have, that each account have. So for verified accounts, if they are not very popular, they don't have too many bot followers in their network. As they get more popular, they accumulate more bot followers in the network. And this is part, in terms of fraction, this is partly because the more popular journalist accounts become a target by the bot accounts to influence their opinions. But when we look at the non-verified bot accounts, the accounts doesn't get this Twitter badge. Early on, when they are not very popular, they have a higher fraction of bot followers. And as they get more popular, the bots and human followers are mixed up, but they get their initial popularity through these bot followers. And let me give one example figure and then show what comes next. So here we have an one account, a politician account in Turkey. And without me telling anything about this figure, do you notice anything strange? Like if you see some irregularities in this figure. If you are thinking about this period, you are right. There's something fishy happening in this time. So let me explain what this figure tells us. On the x-axis, we have all the Twitter followers this account have in a chronological order. So from the first follower to the last follower. On the y-axis, we have the account creation time for each of these followers. So each of these dots in the scatter plot is one follower, and we can see the account creation time. And the color indicates human and bot score, so true botometer. So what's happening here is we detect some activity in 2015 because of this causal curve, because no one can come from future to follow you. So there's a natural causal curve as an enveloping function upon the curve. And we know all these accounts are created in between 2011 and 13. So there's a tons of accounts created between 2011 and 2013, and they decided to follow this account in 2015. And when we look at like within a window, averaging those bot scores, we see an activity where most of the accounts are being social bots, high fraction of the accounts being social bots. So this is how we kind of like interpret those figures, but I also want to give some kind of a warning message. So if someone shows me this figure, let's say 5 years ago, I will definitely jump to the conclusion saying, okay, Do Perinček purchased all these bot accounts. But nowadays, there's more interesting and complicated scenarios one can think of. So let's say a scenario where I created these bots accounts, purchased those bots accounts, and make them follow these social media accounts. And then go to a journalist and saying, hey, you know, these accounts have lots of bots, and I become true by doing this whistleblowing. And then it turned out to be they blame this person, but I might be the one orchestrating all these activities. So we need to be cautious when we are jumping into conclusion, analyzing those type of data. So let me give a couple of examples for organic journalist accounts. So this is one account that we have, like, look, mostly organic, lots of human followers, although there are almost 100,000 of them. There is another journalist account with bot field audience. This is an interesting case because this account has 60,000 followers, and it's created in 2016. And in 2017, just after the account created, it gained 30,000 bot followers. And all these bot followers created pretty much the same time. So they are created between 2016 and 17. And then these accounts gather more audience over time. We can see bot activity for one time. So this account has 10,000 followers and suddenly decides there's a cheap way of gaining followers and pay, let's say, $20 and get 15,000 bots, 15,000 followers. So these 5,000 jump that we can observe really easily with these instruments. And we conducted this analysis in 2019, and we can still see those purchasing activity coming from 2016. So this is kind of like a powerful way to study the audience of those accounts. So what I wanted to emphasize is these social bots have been used to boost popularity. And we can detect these anomalous patterns observed for politicians and journalists. And verification status also, although it's really important, can also might signal some missed signals if the account is popular and using the verification status in a way to disseminate misinformation content. And social bots can be weaponized to accuse politicians buying fake followers, because it's really a challenging problem to point the source of those activities. What we have is only the observations. So far, I've been drawing a really negative portrayal of social media analysis, what we see online, but sometimes social media can be a really useful, beneficial tool as well. Social media is really effective to organize grassroots movements and can be used for social good as well. And let me switch back some different research questions that I mentioned earlier. So in computational social science field, I've been doing two main research directions. One is about manipulation on social media, social bots, fake news. The other is studying the human behavior and how we can model the emotions and well-being. So for this one, we look for the concept that we can call like putting feeling into words. And in psychology literature, it's called affect labeling. So it's used for overcoming phobias or some traumatic events. By writing it down or sharing it helped to heal. So during therapy, these are also suggested mechanisms to overcome those challenges. And by looking at social media, we've did two things. One is previously this type of research done in two mechanisms, either by survey methodology, taking longer time and multiple panel, or putting individuals into fMRI machines, getting shorter time window data collection through stimuli. If it's a phobia, they show the pictures and measure the brain activity. We look at the social media to study emotions. We identify some anchoring events when people are venting the emotions, positive and negative emotions, saying, I feel great, I feel amazing, or they say, I feel terrible, I feel sad. And by anchoring those events, we look at the language used before and after those events. And just to be clear, we excluded those I feel statements not to bias our analysis. And we studied all the events happening before and after and aggregated over hundreds of thousands of people. What we find was by generating those collections of events and characterizing those emotions, compared to our null model, we see positive emotions actually start happening, emerging about an hour before. When we say, I feel amazing, it's actually an hour before we started to feel positive and having a higher mood. And when we reach to peak and excel in our emotions, it dies out about another hour. For negative emotions, what is surprising and consistent with the affect labeling literature is venting the negative emotions is healthy. So when people are venting their negative emotions in social media, it actually starts more than 2 hours to build up those negative emotions. But when people reach the peak and say, I feel terrible, it's take about 15 minutes, really short period of time to return back to normal levels. So people are, by venting emotions, regulating their moods in a healthy way. And we conduct this analysis with different tools and different methodologies. The results were consistent, and we can also quantify the periods of those emotions where we see significant differences. So by thinking about like my research agenda so far, things that are in the short-term period for me is looking for preventing zero-day vulnerabilities, especially for social media misinformation research, because identifying a campaign, identifying an orchestrated campaign a day or two later is not sufficient right now. We need to be really proactive for detecting those activities. And when I developed Botometer, our goal was having a fast and accurate tool working in a single account level. But nowadays we realize having a bot detection tool working for a single level might not be sufficient because bots are getting more sophisticated. And what reveal their motives or automated activities is the coordination among them. So we are extending our tools to look at coordinated behavior among them, and including different modalities working with signals from image and video, and building domain agnostic models. And I see a recent email, a challenge actually organized by Koç University, one of the organizers at Koç University, for multilingual challenges. So I think this is also really beneficial for developing misinformation, fake news detection challenges, or incorporating it to social bot models. So I'm quite happy having those challenges from the natural language processing domain. And another directions that I've been taking is a little bit in the longer term frame, mining social media signals to gain new insights into human behavior and society, how we can model well-being using causal discovery for exercise, eating patterns, and their impact on the health and well-being, and analyzing different altered states through reports and biological and sensory information. So in the lab, we are focusing different focus areas. Misinformation and manipulations and social bot detections is just two of them. Mental health and well-being is another one. And I've been also studying science of science during my postdoctoral research. So I'm continuing to work on that as well, how we can quantify success and popularity in different mediums. It can be academic publication, it can be social media or artistic creation. And going back to interdisciplinarity, we can study different aspects of data in a data-driven field. We look for social mobility and other areas, but we really need interdisciplinary approach to manage and model these complicated systems. And I think one way to achieve this goal is, in other words, is having some gevrek and tea and talking with other people and going these disciplinary boundaries and going beyond our comfort zone. So here are some references and acknowledgements. So thank you very much. I really, yeah, I can take any question right now.
Thank you so much, Onur Hocam, for this really fantastic presentation. It's also, I think, a great example of how computer science meets political science. So on behalf of both the Department of International Relations and GLODEM, I would like to thank you very much again. With that, I think we can open the floor for questions. If you could raise your hand or just unmute yourselves to ask, or if you have an unstable internet like that of mine, you can also put your questions in the chat box.
I can start with some questions. Onur Hoca, thank you so very much for this very informative presentation. I have a general question to start. So what we see from your research is seems like almost exclusively based on Twitter, just one single platform of social network. So I'm thinking, what do you think about, and why is that? Maybe it's very obvious because it provides access to researchers to its data. Do you think it's shaping our also like research agenda in a way, this data availability of certain platforms? Because, you know, Twitter at the end of the day is like a very politicized space, and it's not commonly used in Turkey compared to some other platforms. So I just wanted to ask your opinion about how this data availability is shaping research agenda and what can we do about that?
Yeah, I mean, Güneş Hocam, that's totally right. So one of the reasons that we conduct all this research on Twitter is data availability. Even that availability has become like much more scarce nowadays because Twitter is having much more strict rules when they are giving API keys to researchers like us. So Twitter, because of the data availability and how people have been using, is shaping the research. Most of the election political science type of research is conducting in these platforms. I know colleagues studying Reddit and other platforms for mental health related issues because people are opening up on those platforms and sharing their experiences. So the longer text, more personal information shape mental health research on those platforms. If Instagram was more open in terms of data, I know like a social bot problem on Instagram, I believe much more bigger than Twitter. But they have been used mostly for marketing and mainly for influencer marketing type of thing. Then if we study Instagram's bot problem, then I will probably be collaborating or engaging more with people from marketing research or School of Economics to understand why this business ecosystems is actually using automated accounts. So definitely data is shaping our research question, unfortunately. And I believe like we need to be creative to get even those data in the near future because many platforms are closing up So there's like really great examples of developing browser extensions or developing a native browser to collect user experience data.
Okay, thank you. Well, I'll stop now. Maybe others have some questions.
Thank you, Ecem. Dr. Bollens, I think, has a question. If you could unmute yourself, I think you're muted at the moment.
You can talk now.
Yes, we can hear you.
Yeah, okay. Thank you. See, I'm a complete stupid, just user. So you always need the help of a friend. Thank you for that very, very interesting talk, of which I must admit, most of it I did not understand for technical reasons. But what you also pinpointed in the end, it is an interdisciplinary venture. And I would like to know in which way are you cooperating, for instance, with psychologists, with economists, or how does that work? Because as far as I understand now, you are a research unit at Sabancı, and I do not think that there are psychologists there or
no, actually, we have a great school of Faculty of Arts and Social Sciences. So most of these collaborations that we conduct is happening through collaborations. We have co-authors coming from different expertise. The emotion paper that I mentioned, we have a psychologist, 2 psychologists there, 1 economist, 2 computer scientists. So it's a broad group with different expertise and educational background. For social protest research that I participated in the past, looking for the Gezi movement, has people from School of Journalism. So we collaborated with them. Recently, with the same team, we are studying femicides in Turkey. So in that collaboration, we have 1 person from School of Journalism, another from Media School. So I, as a computer scientist, knows the tools, develop the tools, but I don't have the experience or expertise on political science and many other fields. And I might sometimes look like really not good in these fields. But those collaborations, I try to move from the comfort zones to learn and read. And many times the things that I miss from my colleagues' fields, I try to read and learn. And then we exchange ideas. They are better at the theory and coming with the hypothesis. I try to bring the computational tool sets and methodologies that can be used. So Botometer by design was a tool like that. So we wanted to be open. We wanted to be easily accessible through an API. So people with minimal programming experience can plug it in their analysis and study the automated activities online. So we have people sending us emails asking for support about Botometer from economics, business school, and political science and media school. So I think there are 2 ways. One is like building a tool as a service, and the other is having colleagues that we can collaborate and enjoy each other companies to work together.
Thank you.
Thanks very much. Any other questions? If you could raise your hand.
Yeah, then 1 follow-up, if you allow.
Of course.
I would be interested in collaboration, and especially in the field of psychology and economics. and conflict and peace research, which I'm practicing. And one question, for instance, would be in psychology, where you referred to the field of happiness, well-being. That is a very diversified and rather controversial field, as you probably know. So I would be interested, what kind of theory or scale in well-being would you use or are you using to measure the level? And the same question for economics. In economics, well-being is mostly, especially in neoclassical models, measured by marginal utility. So what is the value of something added to your income or whatever? And this is a very controversial thing because it is in fact outdated, especially through evolutionary economics, which have a complete different approach. What do you use to measure the level of happiness or well-being in terms of economical issues?
I might not be able to speak too much for the economics part of it. For the psychological analysis, what I can say, there's an also debate which tools to use. What we rely on is sentiment detection, and it extracts information from the textual data that how people are expressing their opinions and emotions through text. And there are different approaches, like lexical-based approach builds a dictionary and having a valence values for different words and try to gather some weighted average over those corpus to assign a score for the content. A different approach using the machine learning models can train on a data positive, negative balanced content and build the scores through those machine learning models. So we are relying on those instruments, and this instrument itself needs an evaluation. But what I do in my research is, by looking at the scores extracted from those instruments and having some null models, we look at the deviations where the observations are deviate from the baseline, and try to pinpoint those deviations and try to make a causal reasoning behind those deviations. For the emotion study, we look for the null model, and we assign the causality behind those venting emotions, anything before and after, and we look at those changes. Others can do regression discontinuity analysis for a given event. If I know event A might create some changes, I look at the data before event A, data from data after event A, and look for the deviances between those regression curves, and this is another approach. The third approach, maybe I can share a quick slide to kind of like talk about the previous research that I did, was looking at social media data and looking at what people were sharing online. So here, this was a research that I did at Microsoft Research during a summer internship. So we were looking at the content people have been sharing on social media and try to identify certain events, experiential events, taking a certain drug or having some live event, and comparing any content coming before and after those events. We try to estimate impact of those events for the future likely changes. For instance, taking a lorazepam is a drug for anxiety, and people who take lorazepam and people who are comparable for those people but never disclose taking a lorazepam, we compare those and look at what they talk about in the future. So if people take lorazepam in the future, they are more likely to talk about pharmacies, brain, pharmaceutical, and things like that. So this is an example of like how we can do this open domain analysis to learn action and outcome pairs through social media posts. So here the challenges was, we know the events, we can detect the experiential event. It's the matter of building the control group that are a good match for our people, to those people in our treatment sets. And we were using propensity score matching for that paper.
Thank you very much. So we have 2 questions in the chat box. I will read them out loud so that the audience listening to the recording will be aware of what you're addressing. Burak Özturan is asking, thank you really much, Onur Hocam, for the great presentation. What do you think about the real life impact of social bots? Do you believe that social bots are capable of manipulating the public opinion as a result of information campaign?
Yeah, that's a great question. So thank you, Burak. Actually, I know Burak from one of the Summer Institute of Computational Social Science by Akın Hoca. So he was a great student there. And this is a really important question that we also still try to address. So what we can do at the moment is quantifying the behavior of social bots, quantifying the after story of the social bots, having a controlled experiment and measuring the social bot impact with the current platforms is a little bit challenging. We can do this by the natural experiments that I mentioned. Let's say if Twitter conducts an intervention, we can look at the before and after intervention and we can do a causal story of that. So I have one manuscript that I did a couple of years ago. It's haven't published yet, but I was looking at the effect of censorship. And Twitter has these mechanisms called withheld mechanism. So what they basically doing is they remove the content, replace it with a warning message in certain geographic locations, like countries in Turkey. And I was monitoring the account's popularity and the number of followers before and after they get censored. And actually censorship was backfiring in that case because people were getting more curious in those countries using VPNs, getting the content and sharing as a screenshot. So people are going back and follow those accounts. So that was a case like where we can answer such questions, such causal questions. So that haven't published yet, but I think it's quite an interesting way of combining current social media research with the causal analysis. But there's not many opportunities to answer the implications of social bots. But we can simulate an experimental social network, do a laboratory study, and then manipulate certain aspects of the platform and then answer those questions.
Thank you, Hocam. So Laura Yilmaz has a question. Thank you for this very interesting presentation. I would like to ask how the Botometer was created regarding software development. Which programming language did you use? How did you collect data, etc.? Thanks once again.
Yeah, that was a Python-based system. So all the machine learning component is implemented in Python. We are using machine learning libraries like scikit-learn. We collected data sets that are publicly available. We collected data sets through manual annotations that we collected. For the web interface, we have a Flask application as a server side. We have a database in the backend that we store all the requests. So I guess these are the type of questions that is related to software development aspect of it. For the development cycle, we don't have an automated cycle to upgrade the models. We plan to do regular updates from month to month, but we never be able to achieve that goal. What happens was from regular intervals, we check evaluate the models, if needed, update the features, because Twitter sometimes change their available data. Like recently, they remove coordinates and time zones and things like that. So if we have features that rely on that data, we need to upgrade our models, update our models, and remove those features. Yeah, it's basically a Python application.
Thank you. So the next question is from Yasin Kütük. Onur Hocam, thanks for this valuable and interesting presentation. I check my score in Botometer. I realized when a user has fake followers, he has higher possibility to get higher Botometer scores than others. is it the weight of having fake followers higher than other features? You measured AstroTurf, fake follower, financial, self-declared spammer, and other. That is, most users have a fake follower score while they have nearly 4 times bot score. Thanks again so much.
Yeah, so in Botometer version 3, we didn't have these new features. At that time, we were different models trained on different subset of features. We have a user bot score, we have a content bot score, we have a friend bot score, focusing on only subset of these features and evaluating the results. So with those scores, we have a better sense of like why accounts getting a higher bot score. So if the network score is high, then we were saying, okay, something done in the network automation or in the content automation if the content is high. With this latest version, we divided data set, not the features this time. We try to gather data sets with the similar type of account behavior. So if they are purchased accounts, like having lots of bot followers, we build a model only for those group of accounts. The benefit of that is and then all these sub-models are aggregating their scores for the final score. So it's many sub-models aggregating their results. The benefit of that is sometimes a new account behavior might emerge, and if this new behavior is closer to one of these other, it doesn't dominate the overall results, but we pick up the closest group and then assign the score for that. So it helps for generalizability.
Thank you, Hocam. And the next question is from Salvatore. Onur Hocam, thank you for this thought-provoking presentation. I wonder if we can use machine learning to minimize the effect of bot manipulation in response. Is this bot tech a one-way street? Would there be a bot shield to protect the users from manipulation?
Yeah, that's a great question. So DARPA used to have these program calls for proactive bot systems, and they were also calling like anti-vaccine type of thing. So they wanted to design automated accounts and deploy them into strategic locations to be able to early detect orchestrated campaign or bot activity, and also being able to react quickly. So that's definitely a possibility. And considering the recent advancement in deep learning for adversarial learning settings, one can imagine like designing bot accounts that can adapt their behavior considering its environment. So we can design in theory bots that can find and counteract the misinformation online or other bot activities.
Thank you, Hocam. Pelin Hocam had a question, I think. Yeah.
Onur Hocam, thanks very much for this great talk.
Sorry.
So I was wondering what the feature space you use consists of, because I'm not a Twitter user myself, but so I understood you're using the connections of the accounts. How much of the individual characteristics of the accounts are you using? So for example, the number of connections that account has could be a feature. So I can imagine that easily, but because I'm not a Twitter user myself, I don't really know what the individual characteristics of users are and how much would those affect the outcome. So for example, sometimes you think an account might be a bot because it's going around liking a lot of people's tweets, but those accounts are actually paid to do that. So would those be considered as bots, although they're real users?
So when I was building features for Botometer, one thing that I had in mind is like building up machine learning systems that can work for multiple purposes. So that's why we try to extract as many and various type of features as possible. So we had a different classifier to identify organizational accounts versus human accounts. The same set of features, different data sets. And since we train it on with different labels, the weights learned for different features were different. And among those 1,200 features, not all of not all of them are equally important. Some of them are more important than the other. So actually with 20-30 features, as we did for Botometer Lite, we can get quite a similar accuracy that we have with Botometer. So majority of the features, if we think in that way, is not contributed that much. But for different subclassifiers, some of these features might be more important. They are picking up different signals. So what we extract from Twitter is basically anything that we can, that includes the network features. So in Twitter, collecting the entire friendship and followership network is quite expensive. So that's why we look for proxy networks. We look for the communication data. So with one query, we can get at most 200 tweets. And among those 200 tweets, we build networks of mention network, retweet network. From the hashtags, we build hashtag co-occurrence network and extract properties of these network topologies. So if we see an account that retweets only one account 100 times out of these 200 tweets, that's a suspicious signal, because in this network topology, we see two nodes with a huge strength between these two nodes. So that's kind of like a flag for us. From the content, we can analyze English language content. And with that, we analyze sentiment score, we extract part of speech text. So that becomes useful for spamming type of content, because for spamming or advertisement, they are using different type of language. They use more adjectives, they use less personal pronouns, so that become more prominent if we want to classify spam bot versus normal accounts. And from the user profile, we look at the picture, like whether the user have an default picture or their own picture. We look for the date of creation. We look for the languages of the people that they interact. So we don't expect an account to interact with 20 different followers with 20 different languages. So we also hope to see some different levels of entropy in the language content, language diversity than the normal users. So all these are like different type of features one can think of. And sometimes some really crucial, useful features can be unavailable because of the changes in Twitter. So Twitter decides to change removing time zones, or Twitter decides to change removing some of the coordinate-related, geography-related information. So then, in order to address those changes, we remove those features, or we initiate new ones, include new ones.
Thank you.
I'm muted. So since there are not any questions, I mean, I don't see them at the chat box at the moment, but if there are any, please do let me know. But I will use this opportunity to ask a question myself. How much more effective are deep learning models than models like random forest?
So I think the strength is not what models can learn. I think the deep learning can bring an advantage on what information that we can extract. So if we have a good representation extracted from deep learning system, random forest might still perform quite good. But the important thing is how we generate those representations. So the type of representation I have in mind is like, for instance, when I talk about the network features, we have these graphs and we extract topological features. We extract what is the degree, what is the density, what is the local clustering coefficients and things like that. But there are deep learning technologies that can input any graph and then create a vectorial representation for those graphs. So then we are not like hands engineering, manually engineer those features. So maybe the degree is not important at all, but maybe the clustering coefficients is super important. So I decide clustering coefficients should be in the list of features. But if we rely on a deep learning system, maybe it will automatically pick up some of these signals, although we might not realize which dimensions of this representation corresponds to clustering coefficients, but it might still provide a useful information, learnable information. But then we lose a little bit of the interpretability, because when I look at the graph data, I know it's a set of numbers in a vector, but I don't know what they might be corresponding what features of those data is it might be representing. So especially for language, I think there's a quite a benefits of using deep learning techniques, because we can only go to a certain level by using traditional sentiment analysis or building features from part of speech tags and things like that. But with a deep learning system that can perform in multiple languages, we can achieve that more. But we should be aware of the biases that might be introduced with the data, because I can train a bot detection model using a deep learning model to extract signals from the text. But if my data set's mostly biased towards, let's say, Republican political accounts, then the deep learning classifier pick up the signals about the language that they have been using, not the manipulation or anything relevant to that or any bot language. So with these models, we need to be more careful what data that we feed in. With the traditional models, maybe we can focus more on the features, but what we might be missing or what we include.
Thank you so much, Hocam. We may have a few more minutes for a couple of additional questions if you have any. If you could unmute yourself and ask, or just put in the chat box. And because we tend to have this lag sometimes, like, you know, the moment I say to conclude, a question pops up. So that's why I'm waiting for a few more seconds. But if not, I think I can finally conclude by saying thank you so very much again, Onur Hocam. This was really a fascinating talk, definitely a great start to the new year. And so I also would like to take this opportunity again to thank you on behalf of our lab, MACSSL, GLODEM, and the Department of International Relations for sparing time for us. I also would like to announce that finally we have the previous recordings of the seminars on GLODEM website. We will getting some lost details sorted out, but we will be sending the links to you soon, including this obviously seminar. And the very last seminar of the AI and CSS seminar series will be again in 2 weeks. And we'll be hosting Roxana Radu. She will talk about AI governance. The details will be posted soon on social media, i.e. Twitter, which I'm a new user of. I actually haven't had a Twitter account for about 10 years. I resisted. I finally had to open one because our researchers in the lab insisted very much. So there is that. But I will check actually my score in the Botometer. I hope it's not as high as I imagine it could be. So with that, I think we can conclude if there are no other questions. If there are, you can always feel free to message Onur Hocam, I think, in his email. And with that, I also would like to thank our participants for the lively discussion we had, and hope to see you soon. Have a nice 2021 to you all. Thank you.
Teşekkürler tekrar.